Hello everyone. Thank you for coming our webinar. Nice to meet you. My name is Eddie Hong and I am responsible for the technical support about nGen software. It is the first nGen webinar in Poland, so it is very exciting and pleasant. Today's topic is to train on RC structures as announced in advance. Okay, let's get started. This is the table of contents. First, let me give you an applications of how and where nGen is used worldwide. Next, I will talk about the quick basic tutorial and explain the automatic generating structure drawing. Lastly, we will have question and answer time on that topic today. I will tell you about the building structure, plan structure, and foundation fields in the case of using the project. This structure is an office structure performed in Korea. Seismic design was applied and domestic codes were applied for the load and design codes. Slab applied diaphragm without modeling. This structure is a domestic apartment structure. Domestic apartments are unusually straight structures supported by shear wall against lateral loads about earthquake and windrows. It consists of a total of 12 floors and the slab is plate type. Full meshed modeling was applied. For the earthquake load, the response spectrum load was input. This structure was recently designed in South Africa. nGen is used not only in Korea but also in Africa. As the Twin Tower, it is impressive that the mat's foundation is very thick. VS Code is applied to the design code. Direct analysis, p-delta, and modal analysis were performed. This structure is villa since the first floor is used a parking lot. So it is composed of only column member. This structure is characterized by the second floor consisting of the transfer beam and column. Therefore, those members must be designed by applying a special seismic load. This structure is a school facility. It is RC structure composed of 5 floors. The slab type is modeled as a membrane slab that cannot resist out of plane resistance. The special feature is that the roof is made of a covered shell member. This structure is the design of hotel structure in Poland. The member is composed of frame and wall members, but it is very complex modeling. Eurocode was used as the design code. A number of openings have been reflected, and a number of covered slabs have also been applied, and the plate and release function was applied during analysis. This structure is an irregular building structure. The slab type was flat slab. This structure design was also carried out in Poland. This structure is an RC structure that reflects a large number of openings. The snow load was applied. Irregular flat slabs were modeled in the form of on basement wall is reflected in modeling. The exact purpose is unknown, but it is very huge structure. It is characterized by a full meshed element with the plate. nGen can simultaneously analyze and design RC and steel structures. It is a factory-type steel structure that can be commonly seen. nGen is an optimized program for design steel structures. It is a project applied in Indonesia, and analysis was performed that reflected the shape offset and Penrogen effect. The final modeling was completed by exporting to technical structure to complete 3D modeling. This structure is a parking lot. Members are composed of general structure, frame, and brace. This is a project applied in the Philippines. This structure is the most commonly used pipe rack structure in the plant field. This project was applied when designing domestic power plant. This structure automatically generates the structure drawing using nGen drawing and delivered the final drawing. This is the main control building for the plant field. As a steel structure, ASCE code is applied to the window. When assigning the window, it is very easy to define each area. Enclosed, opening, story-based, and equipment-based window load can be applied. This structure is for water treatment. As a plate structure reflects the opening. This structure is a silo. These circle type of structures are very difficult to model because the inner of the structure is so complex. This structure was able to complete the modeling in a short time by applying the 3D shape wizard. Also, it is great features that the desired load can be applied fully at any position. This structure is a cold shed storage structure. It is characterized by defining the load along the height as a function. In addition, it can be applied to various plant structures. The following is an example of applying the foundation. nGen is also very useful for applying foundation structures such as tanker structures. It is also very optimized for applying isolated footing, compound footing, and metal foundation, including piles. From now on, let's start the main topic of today. This tutorial goes a little faster. However, if you practice the program repeatedly afterwards, you will be able to apply reinforced concrete structure using nGen. This is the basic architecture plan drawing of the structure. We will use this drawing to perform semi-automatic modeling. This is the graphic of the final model structure. Structure design overview. The design code is applied to Eurocode. It is 5-story structure with a height of 3 meters each floor. The member is composed of column, wall, flat slab, beam, and foundations. This is the basic configuration of the program. Main menu, toolbars, worktree, properties window, and navigation tool are essential using items. Description of basic software operation. Navigation tools are used very often for every action. It is method of saving other name. This is a description of snap point settings. Enter the project information by clicking the project information icon on the member tab. We will start from modeling. nGen software consists of two programs with nGen and drawing. First, open the architecture drawing file. Click the Utility tab of Drawing and Layer Setting of CAD Grid. If you select the center line in the drawing, software will automatically recognize the layer. Program automatically recognizes the select entire layer in the drawing if you click the red area. Assign the center line to the center line area in the dialog box. Next, select the column layer on the drawing. Like the center line, or the column layers are visible, and assign it to the column layer area. Next, we will automatically set the layers in the same way for the wall members. The following step is to select and assign the dim layer. All the other layers of information needed for modeling are selected and assigned to the undefined area. When the assignment to the layer is finished, save it and export it to the nGen. If you click export to nGen, and the nGen program will run automatically. The unit system starts with Newton meter. First, create story data. D for T1 means as tower 1. In the Add Story dialog box, input total of 4 floors and a height of 3 meters. Story data are created. Now set the drawing to the required floor. nGen can use 3D or story mode freely. We can see the imported architecture plan on the story mode. First step is the column member. In the member tab, select a column and drag the area from top left to bottom right on the plan. We will assign the material after finishing our modeling. All of the column members have been created in a few clicks. If you select a column, you can check all information of member in the property window under the worktree. Even if the column size is different, it was automatically recognized and created. Next is the word members. There are two options for creating word and reference line. First, let's make a member by selecting the reference line. A dotted red line was created. The word members are in contact with the column members. In this case, it is more effective to make the word by two-point function rather than the reference line option, because it is to match the member according to the center line. Now, it automatically generates a shape offset to match the construction shape. When the function is executed, the shape of the column member is automatically arranged according to the architecture layer, and the end of the word member is also adjusted according to the layer to match the construction shape. Beam members can also automatically generate the center layer by recognizing it. Set for the shape offset about columns and girders by using generation function. Make sure it matches well. Following step is creating the flat slab members. Create the slab member by clicking the snap point along the blue layer that is outline of the slab. Please be careful, don't click the modeling snap point another location. On the plan view, the outer flat slab of F3 is an arc shaped. You can easily make a model any shape using body function in nGen. Create an arc body first, and then the rest of the lines. Lastly, close them to create the face, and then assign flat slab member from face. In addition, the opening of modeling function is used to reflect the opening while viewing the drawing. Enter story data again and use the create members to copy and complete the modeling. You can use the copy function, but in this tutorial, we will use the add function. Members have been created or all floors except the roof floor. Enter the story mode of the roof floor to complete modeling for the remaining columns and walls. The complete members use the generate function to complete the shape offset. From now on, we will assign the material to the member. First, delete the unnecessary default section. We will change the unit system to match Poland engineers and enter the material. The material can be added by selecting the Eurocode DB option C2530. Change the material assigned to the section. The change method uses the tree menu. Define the slab and foundation thickness. To create the isolate footing, choose isolate footing and input 2 meter by 2 meter. Strip footing is similarly created by setting the width of 2 meter. Click the Move command to finish the strip foundation. Select the edge to stretch the member in the X direction. Run pile array function to create a pile footing. First, define the spring property. I used the Korean standard spring property to automatic calculation. Afterwards, you can easily create piles by changing the number of piles to 3 or 2 or 1 and number of 4 through the file wizard. And also we can use the file wizards to create the street file footing. So far, you have seen the quick modeling tutorial we applied for the limited progress of the seminar. If you are nGen user who wants to use the modeling function, please repeat and follow the video file later. From now on, I will assign the load. We will first define the load set and then assign the load. Click the Define tab and Load Set. 4 types of dead load, live load, window load XY direction, and seismic load XY direction are defined. All loads will be assigned from the main menu Load tab. First is self-weight. Next is the slab load. S1 is the office area. S2 is the hallway. And S3 is the balcony. For the reference, the unit system was changed to kilonewton per meter before loading. If you finish the slab load type, select and assign members to each corresponding area. At this time, if you use the filter function of member selection, you can easily select and assign members. Since the modeling process is over, we will delete the CAD tracing file for the convenience. We are going to extract the grid from the created members without creating the grid. Click the OrthoGrid Generator command to extract the grid. Let's check the Generate Grid in the Story mode. Next, input the wind and earthquake load. Wind and seismic loads are automatically assigned using the Eurocode standard. I would not explain detailed description of standard and necessary parameters. The final input load will be checked by turning on/off the check option in the work tree. The following process is the dead load 3, the opening load. Assume that equipment is placed on the opening boundary line. We are going to input the line load. At this time, use the body line. Body is totally different from member. Member is for design, and body is just a tool and an object for assigning members and roles. That load 4 is to input beam load. To check the value of the load, you can check the 1.0 icon on the toolbar by checking on off. All loads were assigned. Next up is analysis. We will set the mesh and load combination before performing the analysis. When the analysis setting dialog box opens, the user can set the size of the 2D member, that is plate type of slab or footing in the Mesh tab. To improve the analysis speed, set the number of processors to 8 in the Solver tab. The following step is load combination setting. We can set various necessary data on the RC tab. It is possible to review the torsional strength check. And the allowable value for the foundation member is changed for the compression and tension. It is also possible to design earthquake-resistant details. This structure would not be considered for a review of the seismic design category and detailed description of lateral resisting system. On the REBA tab, REBA DB provides EN04. Change the REBA grade to Class B. Set the usable diameter. This can be set to be each member. Design can be also supported for checking the alternative rebar. On the Checking Control tab, the member force item is the most important. We can select method how to read the 2D member force for the design. Also, we provide an average distance force in order to calculate the average member force when reading the required member force. The member where column is in contact with the flat slab and footing has high value of member force, so this function should be recommended to perform the design. The load combination can be automatically generated with the base design code. The input load is automatically filtered in the template and envelope function is provided. The tab is divided into strength and serviceability for design check. The stiffness scale factor function allows you to perform design by adjusting the stiffness value for each member. Reduction of stiffness and p-delta analysis would not be considered. Finally, assign area spring to the remaining isolated footings. Now, perform the analysis. The number of elements exceeds 10,000, but the analysis time is rather than 30 seconds. This is because it has a high performance server. Let's change the unit system to millimeter and check the displacement. The view control of the toolbar, change the view option to see the mesh shape. Next, let's check the reaction force. You can check the maximum reaction force value by checking on value in the main menu. Next, let's check the bending moment for the beam member. After changing the member filter so that only beam can be selected, member force can be checked by changing the unit system in real time. Next, confirm the 2D plate member force. It is also possible to check the x direction moment each floor. Let's check the bending moment force in the y direction. To check the shear force, double-click Transverse Shear Force XY direction in the work tree menu. In the analysis results, no significant errors were found, so we continue to design. Road combination has already been created, so there is no need to create them again. Create design group. The design group is very important because it is used for rebar input, design results, and generating drawing. Setting of design group is not mandatory, but it is highly recommended. There are two ways to set the design group. The first method is to apply the member by manually. Select the member and input the group name. In this tutorial, we will apply the automatic generation method and apply manually to the flash lamp. After setting the automatic generation, confirm it by checking on off in the tree menu. Next, change the group name of the flash lab using the manual method. In the stream mode, design groups regarding flash lab are changed for each floor. Design for rebar arrangement is a rebar setting for preliminary designs, including the concept of automatic design. Rebar must be input to perform the design. In this tutorial, first the preliminary design is performed automatically, and then the rebars are modified by manually. Engineers can set boundary for the main and shear rebars each member. It is automatically designed within the category. The principle of automatic rebar is simple. It is to determine the final NG or OK after the software tries to calculate the reinforcement from the minimum dia to the maximum dia. Now, do the design. Lever auto arrangement must be checked on to perform preliminary design in the Run Design dialog box. The design time took about 2 minutes because all elements are checked by all load combinations. When the design is complete, check the total status first. In the initial preliminary design, many nG members were found. Let's check by member or design group. Confirm the nG of beam member with the design report. Next, let's check the nG cost of the column member by table. Lever spacing was nG, about shear lever. If you check it with detailed results, you can confirm the design report. Wall and slab proved to be okay. Next up is flat slab. Some members have been identified nG for bending and shear force. We can check two-way shear and drop panel punching shear in the flat slab member. Stress limitation, linear creep, crack width are also checked by XY direction. Lastly, AS require of main lever can be confirmed by table, design results, and trimming. The footing members are nG in shear member force and required AS lever data. To modify the nG member, please open the Edit dialog command. In this dialog box, design data can be edited by typing text. When the lever data is modified and redesigned, the status of the changed data is determined in the dialog. Click Modify function to define the lever data along with the graphic. After modifying the lever information and clicking the Redesign for checked list, you can check the design result with the changed data compared to the previous design result. Let's edit the isolate footing design data. Because it was confirmed what the region is, the relevant data will be changed. After redesigning, I need to modify the rebar numbers further. Let's assign the drop panel for the flat slab members to perform design. First, create the body face to specify the panel in the related position. You can also draw the line first and then define it as face. Now, go to the Members tab in the main menu and assign Drop Panel to apply it. Define the rebar data for the panel. The defined data can be checked by Design tab in the Tree menu. Additional rebar is a function that can be applied when adding a rebar by defining a reinforcement area. If drop panel or additional rebar is defined, that information will be generated when drawing is created. Next, let's assume that some columns moves 500 mm in the x direction due to a revision. The move command was executed to move members. At this time, the previously defined load information is automatically updated even if the length is changed. So you don't need to worry about that. Move the grid axis as much as the moved member. At this time, please check the shape offset is well defined. Because the members have moved, analysis and designs are performed again. This is a design result after editing the rebar data. Some Flash Lab members are still needed to edit them to all OK members. nGen supports detailed results of pile and column punching for Foundation and Flash Lab members. When the design is complete, we will automatically generate the final structure drawing. On the Report and Drawing tab, click the setting icons. Check if the information on the drawing set is correct. Click the Generate Drawing icon to automatically open the drawing program. To generate structure drawings, use the functions of the Generate Drawing tab of the drawing program. First, let's create a structure plan drawing. Second and fourth floor, and click OK. Processing bar is a process to bring nGen modeling information, including shape offset. First click where to place the floor plan and click once again to set the spacing of the second drawing. In the second floor, you can also see the draw panel information. Opening also seems to be well expressed. You can check the information of the beam and the group name. The member grouping name is in the drawing, which is also used in the member list. Next, let's create a longitudinal detailed drawing. Click Lever Arrangement Manager to set each member individually. If you want to express another mark, you can change the mark name in the Lever Definition type dialog. Let's edit all marks into DB. The rest of the detailed drawing description will be covered in the next third webinar. Check on the longitudinal drawing of the beam member to be created and click the OK button. You can see that negative bending moment area is set to 2 layers. If you select a lever, it can be linked to confirm the position of the member. You can check the cross-section information And you can also check the location of the member using the key plan. It is possible to check the detailed rebar quantities in great details. This is a column detail view. Detailed drawings are automatically generated based on the design code. The bent rebar was well expressed. Key plan and quantity can be checked. The following is a detailed view of the wall member longitudinal direction. Flow information is also available. Rebar number information is not created when the section rebar leader is checked off in the manager. There are two ways to create an elevation drawing. The first method is to select a centerline grid and to directly create a selected location. Click Axis Offset and select the grid. Next, specify the visual range. Elevation drawing is always created by extracting from the floor plan. You can check the reflect shape offset and information about the pile. At this time, we will create an elevation drawing including the drop panel. Next, let's create an elevation drawing by specifying an arbitrary location. Let's include opening, here is the member list. I think this list will be used a lot around the world. Drawing software provides section information for all members. You can see the member size and main and shear bars each group. It is provided for beam, column, wall, slab, footing members. Next, we will confirm the foundation plan and pile arrangement. You can check the basic foundation plan, including information about both rebar and piles. Next up is pile arrangement. Finally, the slab information about the drop panel. The Midas drawing program is CAD program. However, the environment mode has total 3. You can check the drawing mode, CAD mode, and template mode in the window. Drawing mode is an environment that creates auto-generate drawings. The mode shown so far as a demonstration is the drawing mode. The other CAD mode is to create and edit in the same way like AutoCAD. Okay, double-click the CAD mode to enter that mode. We will import the drawing with drag and drop function and edit it in CAD mode. From now on, you can edit like AutoCAD, stretch, delete, and edit dimension lines. Also, you can check the layers. The final edited data can be saved with AutoCAD. And it also provides export function with SketchUp software. Of course, CTB is registered to print output of drawing. This is the end of webinar prepared today. I don't know how you saw it. Do you feel like you finished the project in about an hour? We are proud that nGen is the most optimized program for structure design and drawing creation. Today was the first reinforcement concrete structure. The second webinar will be performed at June 16th. I will let you know again through the email. At the time, we ask for your continued interest and participation. Thank you very much and have a nice day. Can you have a question? Please inquire me.